Hey you guys! Today we have the JGAurora A5S to show you, so stay tuned. Hi everyone! I'm Sandra and you are watching the Raptor YouTube channel. This time, we will assemble and test the JGAurora 3D printer. This is the upgraded version, the A5S. But before we start, don't forget to subscribe our channel and hit like. Also, please check the video description below on how you can help the channel. So, let's start!
Hi guys! So let's check what's inside the box. And inside we have a spool with 300 grams of orange PLA filament. A piece of paper with assembly instructions and a second one with some tips. And the bottom half of the printer. Next, we have a box with parts inside. The spool holder, and the top half of the printer. Inside the box, we can find the power cable, a bag with screws, the warranty papers, a spare nozzle, a bag with metal pieces, a memory card reader, the USB cable, plastic strips, and some Allen keys. In the bag of screws, we get not only the screws to assemble the printer, but also some spares as well. These metal pieces are used to secure the glass on the heatbed. And this plastic strip will be used to cover the edge of the metal sheet on the printer. Inside the memory card reader, we can find the memory card. And this is all that came inside the package. On the heatbed, we have this small sticker. It basically tells us that the blue tape on the bed is and should be used for the initial calibrations to prevent the nozzle from scratching the glass. And this is how the bottom half of the JGAurora A5S looks like. At the front, we have the memory card slot and the touch screen. At the right side, we have the USB connector and 3 connectors that will connect all the connections from the top half. At the back, we have the on and off switch and the input power connector. And at the left side, we only have an opening, but it's covered with a rubber piece. The connector for the heatbed is located on this side. And as usual, let's open the printer and check what's inside. To open it, we need to turn it upside down and take these 2 small screws out. They secure this small panel. And next, we need to remove the 2 screws that are inside the front feet. We also need to disconnect the 2 connectors from the display. These are secured with hot glue, so be careful when removing them. We also recommend to cut these 2 zip ties. They secure the heatbed cable on the inside. Next, we remove the 3 screws at the back, and now we are able to open it. You need to raise the back and push forward. The Y-axis on this one runs on a couple of linear rods inside the printer. The good thing about this is that the axis is protected from dust and debris, but the bad thing is that you cannot reach it to check the belt tension or to lubricate the axis during maintenance. The board is designed by JGAurora, and from what is written, it's the same for the A5S as well. The microcontroller is a 32-bit and has 5 non-replaceable Allegro A5984 drivers. The display is a 2.8-inch touchscreen. The power supply is a big 24 volts and 15 amps. They use ferrules for the input voltage wires, but not for the heatbed wires. And with a small inspection, we discovered that they were not correctly secured, which is a bad thing. As usual, we cut the tin tips and crimped ferrules on these for safer connection. Okay, now for the assembly. The Y-axis comes secured with a small piece of foam underneath. So we need to remove this first. To remove it, we need to take the leveling knobs out and then remove the foam. And the leveling knobs can be installed back. Tighten the leveling knobs until the bed plate almost touches the base and moves freely. Now the top half. We need to remove the small cardboard and foam as well. The top half is very big. It's 480 millimeters wide and 543 millimeters tall, and it's made from folded metal sheet. The extruder is simple but metal, and under it we can see a small switch and a ball bearing. This is the filament runout sensor. The hot end is also very simple. The heatsink is the X carriage that runs on a couple of linear rods. As for the Z, it's driven by a couple of Z motors, one on each side. At the right side, we can see the Z end stop. The X gantry comes fully raised. On this upgrade version, the front metal plate that covers the X gantry is smaller, which allows a better view of the nozzle. There are also more secure points to make the top half more stable. The bottom half has a couple of cuts on each side, and here is where the metal from the top half goes in. In the bag, we have M3 and M4 screws. For this step, we need a couple of M3 screws for each side. The top half needs to be raised, so we used a spare Allen key under it. The Allen key that came with the printer has a flat tip and it's too small, which makes this task very difficult. So we used a long one and with a round tip instead. These screws cannot be fully tightened just yet. The 3 connectors can be connected at this point. They all have different pin counts, so it's impossible to connect the wrong one. Now we need to tighten the 4 M4 screws under the printer. For these screws we need to add washers. Fully tighten the 4 screws and then fully tighten the other M3 screws as well. The X-axis motor cable normally comes already connected, but our cable was disconnected during shipping. And now the spool holder. 3 more M3 screws are needed to secure the spool holder at the back side. The plastic strip is used to cover the edge of the metal at the top of the printer. And this is how the printer looks like. The printer is 480 millimeters wide, 536 millimeters deep, and 543 millimeters tall, and weighs almost 14 kilograms. The printer has a print volume of 305 by 305 by 320 millimeters. Okay. The printer is ready for the first power on. Just connect the power cord at the back side and turn on the printer. The menus are very simple. First, we have the heat button where we can turn on and off the heat bed and nozzle temperature. Move, where we can manually move each axis. Home, where we can home each or all the axes. Print, where we can access the memory card and select the file to print. Extrude, where we can manually push or pull the filament. In level, we can move the nozzle to each corner to help level the bed. Set has a few more options, and we will see that in a second. And finally, a button to change the language between Chinese and English. Pressing Set, we have Fan, where we can turn on and off the layer cooling fan. Change, where we can load and unload filament. About displays some information about the printer. Font and icon allows us to update the display fonts and icons. LCD allows us to calibrate the touch display. And M off or motor off disengage all the stepper motors. There are a couple of adjustments we recommend to do before leveling the bed. The first is the Z end stop located at the right side. From factory, the sensor is secured at its highest position. We recommend to lower it halfway, and the way we do it is using a long Allen key and insert it through the holes on the back side. Next is to level the X gantry. We start by pressing Home and manually trigger the Z end stop when the X gantry is out of the top bar. Next, we press the motor off button, and with the ruler, we measure the distance between the X gantry and the top bar at the left and at the right. If we need to adjust, we can turn one of the Z motors to level the X gantry. When done, we can execute the home sequence. While the Z moved down, we could see both lead screws wobbling, which means that both our lead screws are bent. Next, we heat up the bed up to 50 degrees C, and when it reaches the set temperature, we start the leveling procedure. For this, we use a 0.1 mm thick piece of paper. The back corners are the worst to adjust because the small leveling knobs are not easy to reach, especially the one on the right if you have the filament spool hanging there. We did this several times until all the corners had the correct distance to the nozzle. The last point at the center is to check the flatness of the bed. Now we can place the memory card and load some filament. The extruder has no lever. Instead, it has this small button and pressing it releases the gears, but this makes no sense because it's very hard to use. So to load or unload the filament, we have to use the load and unload option in the menus. Inside the memory card, we find one already sliced model to print, and we started with that. Then we sliced our models to print, but we had issues reading the files. We tried saving new G-code files in the memory card that came with the printer, but the printer insisted on not printing any of those new files. We tried with different memory cards, but even with only one G-code saved, the printer displays lots of rubbish files. The solution we found was to use a 2 GB memory card and with FAT32 format. Then we saved one G-code on it, power cycled the printer, and then it would read the new file. Sometimes when saving new G-codes to the card, we still need to power cycle the printer for it to read correctly the memory card contents. This is very annoying and the manufacturer needs to fix this as soon as possible. This upgraded version is announced to be more stable, but the vertical portion of the printer is still very wobbly. The problem is because this printer is made from folded metal sheet and it's not very sturdy. And this will have an impact on the print quality. Under the blue tape, we have a 3.8 mm thick glass. Without the tape holding the glass in place, we need to use the metal pieces to hold it down. These should be installed at the sides near the edges. If you level the bed with the blue tape, don't forget to level it again. We tested the print resume and it worked as expected. And these are the prints we have made so far. We noticed some extrusion issues with this model and uneven layers on all the prints. This is the model that was already sliced in the memory card, and we can see the issues like the uneven layers on this one as well. The layer cooling was better than what we were expecting from the tiny fan and fan duct, as we can see from the windows on the Benchy. All these prints were made with PLA filament. This printer is a bit noisy when printing, and most of the noise comes from the linear bearings. On the vase, we see a little bit of salmon skin. And that's it, you guys. Don't forget to hit like and please subscribe our channel and hit the little bell to activate the notifications every time we publish a new video. If you like our work and wish to help, you can with our affiliate links posted below in the description, with Patreon or PayPal. Keep following us here on YouTube, Facebook, Instagram, and Twitter. We will see you guys next time. Bye!